Okay, good afternoon, everyone. My name's Hugh Brock, and I'm going to talk about TripleO, the upstream management project for OpenStack. With me are Angus Thomas and Charles Crouch, who are both actively involved with different aspects of TripleO. Charles works on the uh, infrastructure part of TripleO, and Angus is working on the TripleO UI. So what we have for you today is I'm going to talk a little bit about why we think TripleO is so interesting, both for Red Hat and for the OpenStack community. Charles will then present on what is coming up in TripleO in Juno, and Angus will do the same thing for the TripleO UI, where we are and where we expect it to go. Finally, we have a very nice video put together by our own Yardit Sofal, our UX designer for TripleO, and he will walk you through the process of deploying an OpenStack cloud with TripleO, which you can do today using RDO Icehouse. So, without further ado, what is TripleO and why do we care about it? TripleO is a management application for OpenStack. Its mission is to install and provide for ongoing management of an OpenStack cloud. TripleO has its roots in the idea of continuous integration and continuous deployment. So it is very much intended to be a tool that is used to deploy OpenStack over and over again. It is also, however, in my belief, the first OpenStack management tool that really focuses on the needs of the cloud operator, meaning that it provides not only for deployment and flexible deployment, but also for ongoing management of your OpenStack cloud. Now, why should we care about TripleO? One of the big things that I think is really important about TripleO is that it is an upstream program within OpenStack. OpenStack has not until TripleO came along had a standard installation tool that is part of OpenStack and that all OpenStack users have a stake in. The installation, deployment, management process has been fragmented across different projects, different organizations, different companies, that sort of thing. We at Red Hat and in the RDO community believe that the success of OpenStack itself very much depends on the existence of a management app that is part of OpenStack itself. And TripleO has become that tool. So we're very heavily invested in it, and we think that its success is critical to the success of OpenStack as a whole. Now, so what is TripleO exactly? It's a management app for OpenStack. It uses OpenStack components to perform the management of OpenStack. This is a little bit mind-bending for people, and I don't like to focus on it too much right at first. The point is that in OpenStack we have a very solid orchestration tool, Heat. We have a very nice scheduler, Nova. We have a way to launch things on bare metal, the bare metal driver, which is becoming ironic. And we have a nice way to monitor things, which is Ceilometer. You take those tools and a few more and put them together, and you have a management application. And the goal of TripleO is to use those tools as a management application for OpenStack. TripleO is focused on the needs of the operator, meaning that not only does it offer flexible deployment of an OpenStack cloud, it offers monitoring via Ceilometer, scale up and scale down via Heat, and lifecycle management. You will be able to upgrade your OpenStack deployment using TripleO in the relatively near future. So this is a very big deal for us. We think it's really important that OpenStack have a management app that really satisfies the needs of the cloud operator. Other thing I will quickly say about TripleO is that it is right now running in parallel with the upstream OpenStack gate. So we have at Red Hat and also at HP, we have racks of equipment that are running all of the running CI as upstream OpenStack patches go in, just as the regular OpenStack gate does. We're running it non-voting, but we run the CI using TripleO. So the eventual goal for TripleO is to be part of the gate, so that you will, as patches go in, they will have to pass the TripleO deployment test in order to make it into a tree. This is going to make OpenStack much more robust, because we have to be able, it tests our ability to deploy OpenStack, and also means that TripleO will always be sort of field tested as an installer. I think that's all I have, so I would like to turn things over to Charles Crouch now, who will tell you a little bit more about how TripleO actually works and what's coming in the next release. Over to you, Charles.
Thank you very much, Hugh. Let me just share some slides. Can everyone see this?
I saw it for a second, but it's gone away now.
There
we go. It's up.
Okay, great. So my name's Charles Crouch. I'm an engineering manager at Red Hat, and I'm going to spend a few minutes today talking a little bit in more detail about TripleO and also its relation to audio and the some of the roadmap items that we're looking at. So I'll go in and just reiterate some of the points that Hugh made around what is TripleO, and also define the InStack project, and then we'll go through the goals for some of the upcoming releases. So as Hugh mentioned, TripleO is an official OpenStack program, and its goal is to provide deployment and management capabilities for OpenStack. At the wiki link there, you can get a lot more details. It actually consists of 12 sub-projects that provide various tools to help that process of deployment and managing OpenStack. The other key element that Hugh mentioned was that one of the goals for TripleO is to try and utilize OpenStack services as part of this management application. So, for example, when you try and deploy a OpenStack cloud, you define that as a heat template. You then utilize heat to call into Nova to go and deploy the nodes that make up your cloud, and Nova will go and look in Glance to see the images that you want to actually be the fundamental underpinning of your cloud. So it is a little confusing at first. Don't worry about that. That will pass. Hopefully the next slide here will make it a little clearer. So I mentioned that the key thing is using OpenStack to deploy OpenStack. That essentially means we've got two clouds. The one on the top half of the screen here is the production cloud. That's the one that you're ultimately going to care about. It's where all of your tenants will run their workloads, and this is the thing that we're actually trying to deploy. Then, and this is what's colloquially known as the Overcloud. Then there's another OpenStack install, which is described on the bottom of this slide, and this is actually the management application. So this is what we also know as the undercloud, and it contains things like Nova and Heat and Glance for just the use cases that I described. This is the one that, as a cloud operator, you'll be interacting with most, and using this cloud to deploy your production Overcloud. So I've mentioned InStack. at the lead off. So what is Instack? It's really just a tool to make using the TripleO projects easier on top of RDO. So it makes it easier to deploy OpenStack on top of Fedora, CentOS, and RHEL. You can see there's a link to our Getting Started guide to how you would deploy OpenStack using Instack. Basically, it walks you through the process of using the RDO RPMs versus pulling the very latest bits from all of the different open source projects. So you can get you can install the stable Icehouse branches of the RDO RPMs using this process. And also, it's got a slightly simplified deployment model compared to upstream. So there are fewer, a few less steps involved when using Instack versus the full upstream version of TripleO. So I encourage people that are interested in RDO and TripleO to go and check out Instack. The current state is that, first off, it's not production ready. It's aimed at test deployments and smaller deployments, not aimed at trying to deploy production OpenStack Cloud at the moment, though that is obviously our ultimate goal. It will let you deploy either to multiple bare metal machines or a single host that has multiple VMs installed on it. The final production cloud that it will let you deploy today, it will support there being a single all-in-one controller node in that Overcloud, one or more compute nodes, and then optionally you can have block storage and object storage nodes. So Cinder and Swift. It uses Cupid for the messaging broker, and right now it does require all the nodes to be running Fedora 20 and SE Linux to be set in permissive mode for the install to complete. So now let's look a little bit about some of the goals that we have for both TripleO and Instack. In the very short term, we're looking to improve the deployment experience that you can get with Instack using the RDO Icehouse release. So we're going to look to move to RabbitMQ for the message broker, and also let people run with SE Linux enforcing so they don't have to set permissive on their nodes. And then finally, we're, as I said before, right now we only deploy on top of Fedora 20. We want to extend that out so that we can let you deploy OpenStack on top of RHEL 7 and CentOS 7 when those are available. Some goals that are a little more further out there into the Juno release. We want to move from just enabling your production cloud just to have a single controller node to let it have actually a HA, a highly available setup. So enabling you to deploy 3 controller nodes. So that obviously is going to require us to have to let you install HA messaging, HA database, and then HA OpenStack core services, either active-active or active-passive setup. We're also going to be looking at basically streamlining some of our usage of heat within TripleO to remove some of the plumbing that we do around templates and make use of provider resources and software config features that heat offers. And as Hugh mentioned, we're targeting trying to get the TripleO CI jobs into the OpenStack gate. That's very important for us because right now, when somebody can commit a change into Nova or Neutron that breaks TripleO, and those developers don't know about it until somebody on the TripleO team comes and says, "Hey, I think you've broken us." So by adding TripleO CI to all of the core OpenStack projects, we should be able to prevent those just random changes that go in and break TripleO. They'll be blocked before they're allowed to merge into the other core projects. So I've also outlined here some of the longer term goals. We've got specifications started on a lot of these items that you can go and review in more detail. The first one is about supporting the ability to, once you've got an Overcloud, your production cloud deployed, well, you're not going to want to stay on that version forever. You're going to want to upgrade it. And what we want to do is to be able to support upgrading that on the Fedora family of distributions. Upstream, we've been able to verify that the image-based upgrade approach that TripleO uses works on Ubuntu, and we want to bring that same support to Fedora. We're also looking at how we can deploy Overcloud services in Docker containers and containers in general. The goal there is just to try and reduce the footprint that you need to test out a TripleO install. So right now you either need a bunch, 3 or 4 bare metal machines, or a big, probably 16 gig machine that you can run 3 or 4 virtual machines on. And we think that moving some of these services out of VMs and into Docker containers could be a way to reduce the footprint required. On a similar model, we're looking to see if there are ways that we can deploy TripleO onto a public OpenStack cloud. So instead of you having to set up a set of machines in your lab to test this out, or have a big box with a bunch of VMs on, you could just log into a public OpenStack cloud, such as the ones from Rackspace or HP, and then just deploy TripleO on top of that as a means to test out and get your feet wet with the TripleO deployment process. So we're looking to have better testing of the TripleO components. A lot of our testing right now is done at the sort of integration layer. We're looking to add in a lot more unit testing capability. And then finally, there are going to be big changes going into Heat around making that more reliable, particularly in the use cases of deploying thousands of nodes into your Overcloud. So for people that are want to deploy really large production clouds, we want to make sure that Heat is able to better support that deployment model. So if any of that sounded interesting, please jump on #TripleO on freenode and start getting involved. We'd be very interested to have more participants. Okay, so with that, I will hand it over to Angus.
Thank you very much, Charles. So I am going to talk about the TripleO UI and what we are intending to do with that in the scope of the Juno development period, and possibly a bit beyond that. And then you'll actually get to see the video of the TripleO UI after I have done so. So let me start by sharing my screen so that I can show you a set of slides. I will rely on my colleagues on the hangout to tell me I think it's going to. Excuse me. Right, I hope that you're now all able to see my slides in some kind of reasonable definition. So, as I say, the TripleO UI, which is, as the name suggests, the web user interface which actually sits up on top of the components that Charles and Hugh have discussed. One important point to make is that the TripleO UI depends on Tusker, and I wanted to mention Tusker because this seems the best point in our overall pitch to do so. Tusker basically extends TripleO by adding a REST API. The API lets people plan out their Overcloud deployments and their updates to their Overcloud deployments, and it cooperates with Heat sits alongside Heat. The Tusker API lets people assemble the roles, which is essentially the purpose that a machine is going to be put to when the Overcloud is deployed, and all the additional configuration and so on. And Heat actually then does the deployment. So the Tusker API is an important component in the total stack, which the UI depends on. Tusker also has a command line interface, as well as the web UI, which I'm going to talk about in more detail. And the command line interface, much like most of the command line interfaces which go along with APIs within OpenStack more generally, has a Python client code, and it sort of operates in a very similar way to the other command line tools that OpenStack components have. Excuse me. So the capabilities that the TripleO UI exposes come from the Tusker API, but also from a set of other underlying APIs for OpenStack components. TripleO UI is implemented as a plugin to the Horizon dashboard, and people who are familiar with OpenStack will know that the Horizon dashboard is essentially a fairly thin and stateless layer which represents the capabilities of the underlying services. We follow the same model essentially in the Tusker UI and reuse a lot of the same code. In fact, a lot of the work that we are doing in developing the TripleO UI is actually work done on the core Horizon code base, because we kind of extend Horizon. So wherever it makes sense, we add features directly into Horizon and inherit them into the TripleO UI rather than duplicating anything. Excuse me. So in terms of scope, the UI handles a couple of cases. There's the initial deployment where you start with a bunch of physical machines and you build out your Overcloud. But there's also ongoing management of your cloud. So you could, for example, use TripleO and the undercloud model to do an installation, and then when you're finished, you could remove all trace of the undercloud. But the more interesting case, in some ways, is to have a persistent undercloud, which is a persistent management layer that lets you control one or more overclouds. And when you have a persistent management layer, you get into things like receiving notification and monitoring state and tracking hardware availability over time and so on. And the UI does a lot of that. There are two main aspects to what the UI does, which are hardware management and overcloud management, and I'm going to talk about what's coming at a fairly high level for each of those. So tracking hardware metrics is a key aspect. There's essentially a chain which starts with Ironic. Ironic is a bare metal hypervisor and is being developed as a replacement for Nova Bare Metal, which currently does the same thing. It allows operations to be done on physical servers in much the same way that a hypervisor allows virtual machines to be manipulated, stopped and started, and OS images to be assigned, and so on. One of the things that we're going to use Ironic for in the near future is polling a physical hardware state. Ironic uses IPMI to talk to the servers, gets a whole load of metrics about the hardware state, which can include things like fan speeds and all kinds of low-level information about what the machine is doing. And Ironic then exports that information to Ceilometer. Now, Ceilometer is OpenStack's monitoring and metering solution, and it receives notifications and alerts about all kinds of conditions from all kinds of components and stores them and makes them available to web UIs or any other tool that wants to use them. So Ceilometer will get all of this hardware state. We'll also get host OS state from physical servers via SNMP, and then we're going to aggregate all of that information in the TripleO UI so that operators get a view of the actual state of the physical hardware that's running their cloud. excuse me. So this screenshot is here in order to show you the graphs at the lower part of the screen. We have recently done a lot of work. A developer called Anna Krivokovic has added graphing support into Horizon, and then we inherited it in the Tusker UI, and it will allow us to show a whole load of the kind of graph and state metrics that operators expect to see when they're concerned with managing hardware, which is really what the Undercloud is largely about. The next screenshot shows a wireframe by Jaromir Zufal of how we anticipate this is all going to come together by the end of the Juno cycle. This is a detailed view for a physical server, and there are the graphs at the top of the screen there, which I showed you the real-life implementation of a moment ago, showing you how busy the thing is, how much resources are being used, and so on. On the right-hand side, there's a drop-down box full of operations you can do on this physical machine, which ends up talking back to Ironic, which is the hypervisor equivalent. And then lower down in the bottom right corner, there is service-specific stuff. This flavor consumption tells you how this machine, which is running Nova Compute, is actually being used, the combination of virtual machines which it's hosting. So you get to see both the state of the physical machine and some information about the OpenStack specific job that it is doing. Other things which we are going to have in the fairly near future include auto-discovery of physical servers. At the moment, as you'll see in the demonstration video at the end of this, we have a manual registration process for setting up new machines within our management system. We're going to have support for auto-discovery, so that when machines are plugged into the network and boot up for the first time, there's a Randis which probes them and adds them to the database automatically. That's obviously a far more scalable solution. And asynchronous alerting, we're going to have support for pushing alerts on hardware failures or whatever it might be into the web UI, so that operators get to see these things sort of immediately as they happen. That's not an alternative to sort of having a searchable archive of history of those events. And we're also going to avoid the temptation to attempt to re-implement a alerting and escalating policy engine like Nagios. So if you wanted a complex set of rules about exactly how to send pager messages in the middle of the night or whatever it might be based on alerts, that's definitely out of scope for the TripleO UI, and something like Nagios is a better fit. But we're still going to have alerting support for operators who are actually sitting and using the thing. We're also working on hardware-specific extensions. So Ironic has support for drivers which expose the features of particular pieces of hardware, and the DRAC management cards that often come with Dell servers are a good example of this, as well. You can write drivers within Ironic which expose all of the extended underlying features of a piece of hardware like that. What we want to do, and this again is work that we're doing initially within Horizon, is adding support for AngularJS. And we want to use that to make much more rich and dynamic views in the web UI, so that, for example, when there is a piece of hardware which is under management and it has a DRAC card, we can update the views, extend the views, show additional information and additional controls to take advantage of that card. And we can take the same model and apply it to all kinds of other different pieces of hardware, storage controllers, and so on. But Angular and getting that into Horizon is going to be key to allowing that sort of dynamically reconfigured and extended UI. Excuse me. So that is what we are currently squaring up to in terms of hardware management. The other aspect is managing the overcloud. Once you've got a cloud deployed, you need to be able to do stuff with it. And in order to extend what we currently support there, we're doing a lot of work which again has general implications and general benefits for the Horizon UI, and goes beyond narrowly just the TripleO use case. We're doing a lot of work to extend the interaction between between Horizon and Heat. So the Heat team and Jordan and Mara are currently squaring up to several tasks, including nested stack support. I don't want to digress, but Heat has a fairly complex specification, what's known as a Heat stack, of exactly what the Overcloud should look like when it gets deployed. All of the metrics and the parameters which are needed to build out the Overcloud are fed into Heat from this stack. Nested stacks allow reuse of components. You can have a little bit of information that describes a particular aspect of your Overcloud and use it again and again by nesting that little bit of stack definition into a larger use case. Horizon currently has a topology view, and we're going to extend that so that you can drill down where you are using nested stacks, nested templates. You can drill into them, and you can see more detail about those. And another useful view that we are going to add is a quota check. Users, when they are operating within Horizon, are they're subject to lots of constraints and permissions and so on. But one of the things that users have fundamentally is a quota. They're allowed to use an amount of the resources that OpenStack offers, virtual machines and so on. We're going to add the ability to take a stack, so a thing that you would potentially like to launch, which is a combination of virtual machines, storage volumes, whatever it might be, and run a sort of hypothetical case of saying what will happen to my quota usage if I attempt to launch this. So it may well come back and say you don't have sufficient quota to launch that, and if you try it will fail, which is a useful thing to know rather than finding out by actually failing. Or it'll tell you that you can have one or two of these things but no more. And the final thing that I wanted to mention is a slightly longer term goal, which I don't anticipate that we are going to deliver in the Juno development cycle, which is currently underway, which is a more sort of intuitive, user-friendly interface for composing these stacks. If users are assembling what they want their Overcloud to look like, the jobs they want to put onto their physical servers, it would be nice to be able to sort of select those jobs from a list of known and defined jobs and drag them around and pull in extra instances into a graphical view and assemble the thing in that way. That, as well as being useful for defining a heat stack for TripleO, that kind of visual representation of a complex collection of elements would be useful across lots of aspects of Horizon as well. So we want to get to that, but it's complex and it's a slightly longer term goal. At the moment, we need to do a lot of design work and work out exactly which problems we most urgently need to solve and what the use cases are. And that is it. That's the upcoming stuff, and I hope it all kind of makes sense. It will probably sit slightly better in context after the video, which you'll see shortly, which shows the current state of the UI in operation. Okay, thank you very much.
Excellent, Angus. That's a lot of good stuff. I am going to next thing we're going to do, everybody, is run a video of the TripleO installer that is currently upstream in RDO Icehouse, which Yarda was kind enough to make for us, and it just shows the steps that a UI user would take, starting from having installed an Overcloud, or excuse me, installed an Undercloud to going through and deploying OpenStack. We're going to play this video using the YouTube plugin for this Hangout. If you do not have that plugin enabled, then what you do is you click the little red square with the right arrow in it in your Hangout toolbar on the left-hand side, and you should then be able to see the video. We found that the video may not record correctly, so if you're watching this recording, you may not see the video itself. However, I'll just quickly put up here a link to that video so that you can all see where it is. So you can watch that on your own time, or you can watch it here with us. I hope everybody can see that screen. And I will now move on to playing the video. Let's see here. Okay, so unfortunately, I'm told that that video is not streaming at all. But as I said, the URL is here, and I'll just leave it up there for a few minutes. I think now we can move on to questions. If anyone has any, we will be monitoring the IRC channel. So one question Rich had was whether the TripleO installer would eventually replace Packstack for simple test deployments and that kind of thing. My feeling about that is that yes, eventually it will. The in-stack installer that Charles mentioned should eventually become able to deploy an entire OpenStack deployment on a single machine. And it should really be quite easy to use from the command line. We're not quite there yet, but I think once we get there, a deployment within Stack and TripleO will be both more reproducible and reliable, but also closer to what upstream is doing in the gate. And for that reason, you'd want to use the same, if you can use exactly the same tool that the gate is using to deploy OpenStack and test it, then I think you're money ahead in general. Other questions? Okay, looks like we don't have any other questions for now, but you can find us on freenode and #TripleO, and also #RDO, and we're happy to answer any other questions there that you might have. Thanks very much.